Hello everyone, welcome to the channel Physics Solutions. Our today's topic is going to be Hooke's law. Hooke's law is very simple to understand. Let's say if we have a spring in our hand. The original length of the spring, let it be hanging from a rigid support, and its original length, let's say it's 14 centimeter. Now I have some weights with me. Now let's say if we are hanging this 10 gram of weight to it, what will happen? Obviously the extension will take place. So let's say the extension is 1 centimeter per 10 gram. Now if I keep on adding the weights to it, what will happen? So if I hang another 10 gram to it, now the total weight hanging to the spring is going to be 20 grams, right? So the extension is going to be now from like 1 more centimeter ahead. So it is going to be 2 centimeters from the original, right? So 1 centimeter and 1 centimeter. So in total 2 centimeters. So every 10 gram the extension is going to be constant. This is how the Hooke's law works. So let's try this particular thing with a simulation. Now I am having two springs with me. Now looking at the two springs, if I increase the strength of second spring and if I keep the strength of first spring like this, which spring is going to be more delicate? Obviously the spring number 1. So if I hang to spring number 1 50 grams and spring number 2 again 50 grams, which spring is going to give you the more extension? Obviously spring number 1. It has been extended from this blue line to green line. So the extension of the spring, the original length of the spring was till this blue line. So it was 48 centimeters. Now from 48 centimeters it has moved to 60 centimeter for spring 1, and spring 2 the original length was 48 again, and from that 48 it has moved to 52 centimeters. So here we can see that the original length of the spring, if I remove the weights, the original length is going to be, we can clearly check the original length is 48 centimeters. So after putting 50 grams to each of the springs, we can see the delicate one extends more and the thick one extends less. This is why, because the spring's constant is high for fat string, thick one. Okay, so what we can understand from spring's constant, so if the spring is delicate, the spring constant is going to be less. So spring's constant is nothing but the extension power of or you can say the power of a spring. Like we need more force for extending it, that means its spring constant is high. So let's say that spring constant is K. Okay, now if I have a thick spring like this, obviously this spring is going to have more springs constant. Springs constant is high for this. Okay, so let that springs constant be denoted by small letter K. The very first thing we need to understand is springs constant. What that constant is nothing but it's the power of a spring, or you can say the strength of a spring. So if we need more force to extend it, that means its springs constant is high. If we need less force to extend it, like so, we can see the spring number 1 is delicate, its springs constant is less. Spring number 2 is thicker, springs constant is high. If I make both the springs of the same strength, that means both the strings are identical now. So both the strings will have the same springs constant. So if I say identical springs, that means their spring constant is also going to be the same. Now let's begin with the extension. Now if I see the original length is 48, but after that, the after attaching 50 grams of weight, its extension has become now 56. We can see over here. So it is now 56 somewhere over here. So 56 is nothing but the extension. That means after 48, 56 minus 48 will give you how much? If we can check out that. So 48 and 56. If we subtract the two, we are going to get 8 centimeters. Okay. So here we got extension as 8 centimeters. So extension is nothing but, in that case, is original length and the new length. So new length minus original length. That will give you 56 minus 48. That is going to give you 8 centimeters. Now let's see, if I attach 100 gram to this particular spring, so that means I am attaching more 50 grams to it. So what happens? The original length of this spring was, let's see the blue line again, it was 48. That is not changing, every time it is going to be the same. Now the new length of the spring is come out to be 64. So 64, if I check, it is going to be the new length. So new length is 64 and the previous length was 56. So 64 minus 56, it is going to give you, again, this is 5 and 14, 8 again. So that means every time when I am attaching equal amount of weights, I am getting extension as 8 centimeters. So the previous length minus the new length minus the previous length is going to give me the extension. So this is how we can get for each attached weights. Now let's say the weights attached, you are going to plot it on x-axis. So let's say the force, weight is nothing but the force in newtons, right? And the extension, let's say the extension is going to be expressed as E. So E in centimeters we are going to plot. Okay. So here we are going to plot this particular thing. Let me take an eraser. So if I'm going to plot, let's say 10, 20, 30, 40, 50, 60, 70, 80, and here the extension is like, in the form of 8 centimeter as we could see in the experiment. So let's say it's 10 grams, 20 grams. So let's take it as like, in the form of Newton. So if we are taking it in newtons, let's imagine that like, it's not in grams, it's in newtons. So we can convert grams to newtons by, like, multiplying it by converting grams to kg and then multiplying it by 10. So that we are just avoiding over here. So we can just take 10, 20, 30, 40 to make the experiments look simple. 60, 70, 80. So let's say that it's already like, we have got this particular thing in like, newtons. So we can just plot force in newton, 10, 20, 30, 40, 50, 60, 70, 80. And here we can say that it's 10, 20, 30, 40 centimeters. We can just keep it as simple as that. Now here for the first 10 grams we got extension as 8 centimeters, right? For the second 20 grams we got extension as 16. So we are going to get somewhere over here, right? 30 grams we are going to get the same, that is powers of, like, multiplications of 8. 8 ones are 8, 8 twos are 16, 8 threes are 24. You are going to get somewhere over here 24, right? So as we are keeping on, if we will keep on increasing the weights to it, what will happen? It is going to give you the same amount of extension for every 50 grams over here. So let's say for 10 grams it was 8 and 20 grams it was here we have taken actually 50-50. So we can do experiments with different weights also. So let's imagine, let's assume that for every 10 grams the increase in the length was 8 centimeter. So if we are going to, it is just to understand that whenever we are going to plot extension and force versus extension graph, what are we going to get? We are going to get a plotting in such a way that if we try to join all the points, we are going to get a best fit line. If you draw, we are going to get a straight line passing through the origin. This proves that whatever force we are taking and extension which is happening, that is directly proportional to each other. Okay, so we can take extension as E, or we can take extension as X. In most of the IGCSE textbook, it is like given as X also. So we can take it either E or X. It's your wish, the extension. So here, if I remove the proportionality sign, I have to give equal to sign, and then for that we need to give some constant. Let that constant be small k, that is Spring's constant. So F is equal to kx is nothing but this equation we need to remember for Hooke's law. So this is nothing but the Spring's constant. Whatever spring we have taken, that manufacturing company can let us know what is the spring constant, or we can use the spring and we can do this particular experiment by increasing the force on it, and then we can find the force versus extension graph. And from here, so if I use this particular formula, F is equal to kx, and I need to know the spring constant of this particular spring which we have used over here. So for, let's say, for k, the formula becomes, if we are going to rearrange the alphabets over here, we are going to get k is equal to F upon x. So if we know the value for force, let's say for 10 grams it was 8 centimeter and is the extension, so 10 upon 8. So the spring's constant is going to be over here is 10 upon 8. When we just divide it, you can use your calculator to get the answer. So when we divide this 10 by 8, you are going to get 1.25 as the answer. So this is nothing but, it doesn't have any this particular thing is force versus extension, force upon extension. So force is 10 and 8 is the extension over here. So Newton per centimeter or Newton per meter, depending upon the units which we have used over here. So this could be the unit for spring's constant. Every different spring has their own spring's constant value. If the springs are identical, as we can see in this case, both the springs are having the same spring's constant or same spring's strength. Okay, so Hooke's law explains us that whenever you keep on adding the loads to the spring, the extension which is happening to the spring, it is always equal if you are for equal amount of weights. Now what happens? So if we are going to plot the graph of force versus extension, or extension versus force, however we can take it on x-axis or y-axis, it doesn't matter. So what we can do, we can see over here is the extension, whatever is happening for equal amount of weights, both are happening in proportion to each other until you can see the point P. So they are in proportion, like for equal amount of weights which is increasing, the equal amount of extension is happening. That's the reason. So till this point we can see that the extension is happening proportionally to the force. But at this point P, beyond this point P, if we keep on increasing the force or the weights which we are increasing on the spring, the extension won't be that much. The extension is little, right? The extension is going to be not in proportion with it, and because of that, what happens? We can say that the spring has stopped behaving the Hooke's law. the Hooke's law is not applicable beyond point P. So this point P is nothing but it's called limit of proportionality. Now we have already known the word as proportionality. So limit of proportionality means that when we extend the spring beyond this limit, what will happen? The spring is going to be deformed permanently. So this point is called limit of proportionality. So we can go till some region over here, and then we can get a breaking region also, that we are not going to deal with now. So till here we can see that the spring is following the Hooke's law. Hooke's law says that force is directly proportional to extension. Okay, so they are behaving till point P. That's point P. Now once we get in the table, like if we plot a table of force versus extension, so for every amount of force, how much is the extension happening? So let's say 10 gram, the extension was 8 centimeter. Then 20 gram, the extension was again 8 centimeter. So every time the extension which is happening was 8 centimeter when we subtract the previous length from the new length. That's how we get the extension. So once we get a we stop getting the value which is not equal to 8, or it is going to be less than 8 or something. So 30, let's say we got it as 5 centimeters. So that's the point where we can say that at this point we say that it's a limit of proportionality. We should stop loading, and then from here we can find the limit of proportionality is here. And if we here we can say that the spring has stopped behaving, it's not Hooke's law is not applicable beyond this particular point. So this point is called limit of proportionality. So when we plot a graph and we get the graph like this, that means this point is here. Till here the Hooke's law is applicable, and beyond this the Hooke's law is not applicable. And when we try to deload the spring, let's say if we are attaching the weights to the spring, let's say one time it's 50, then another time it's 100, then another time it's 250 grams, as you can see over here. So what will happen when you keep on detaching the weights, when you keep on removing the weights every time, small weights, when you keep on removing, let's say the maximum weight attached to the spring is 10, 20, 30, 40, 50 is the maximum. So when I keep on detaching the weights in the 40, 30, 20 and 10, I'm going to get the original shape of the spring again if I have not crossed the limit of proportionality. That means the spring is not elastically deformed. So if we keep on attaching the weight beyond this limit also, there will be one point where it is going to be elastically deformed. So we understand that once it stopped behaving, the Hooke's law Hooke's law is not applicable. From that point we should stop loading the weight, and from there we can unload and check that every time you unload you are going to get 8 centimeter less, and the spring is coming back to its shape. So when we keep on loading and loading and loading, there comes one point where the spring is going to break. That is, it is going to be permanently deformed. So Hooke's law is nothing but it is only that the Hooke's law is the equation which we need to remember. F is equal to kx. That proves that whenever you are going to load a spring with certain weight, certain force, the extension is going to be constant. And Hooke's law is only applicable for springs, not rubber bands and any other elastic material. So this is the limitation of Hooke's law. So F is equal to kx is the equation which we need to remember, where F is the force attached, x is that extension happening, and k is the spring's constant. And how do we find extension? We can find extension by subtracting the new length, the previous length minus the new length. So as we can see over here, the new length which we got over here, like every time it is extending at 4 centimeter, then it became 5 centimeter, then it became 6 centimeter. So 6 minus 5 will give you 1. and then 5 minus 4 is again going to give you 1. So that means the extension happening over here is going to be 1 centimeter. So every, like, different experiments, different springs give you different kinds of extensions. So we can perform this experiment through simulation, or we can perform this experiment in labs by taking springs with us, and then we can plot the graph of force versus extension. And when you plot the graph, you are going to get this kind of graph where we can see a straight line, and then we can get a curve. So till the point where it is straight line, we can say that it is following Hooke's law, and then beyond that it is not going to follow Hooke's law. So this is all about Hooke's law. Thank you.